Welcome to the DIY Honda Garage channel. The DTC P0122 indicates a low voltage condition in the throttle position TP Sensor A circuit. The TP sensor is a crucial component located within the throttle body assembly that monitors the position of the throttle plate and provides this information to the Powertrain Control Module, PCM. The PCM utilizes this data to adjust the fuel injection and ignition timing, ensuring optimal engine performance. When the output voltage of the TP Sensor A falls below a specific threshold, it signals a malfunction, prompting the PCM to store this diagnostic trouble code, DTC. Addressing this DTC is essential for maintaining vehicle performance and achieving fuel efficiency, as it directly affects engine performance metrics. DTC P0122 signifies that the throttle position TP Sensor A's output voltage is lower than an acceptable level. Relative to component roles, the TP sensor is integrated with the throttle body and measures the throttle angle, translating it into voltage signals for the PCM. The throttle body is typically located between the air intake and the engine, featuring the TP sensor as part of its assembly. The PCM uses the voltage input from this sensor to determine the engine load and adjust its operation accordingly. When the voltage is inadequately low, the PCM registers an abnormality, triggering the diagnostic trouble code as a precautionary measure to maintain engine integrity and performance. Several potential causes can lead to the appearance of DTC P0122. A defective throttle body itself could directly impact the performance of the throttle position sensor A, causing the voltage to drop below specifications. Additionally, there may be an open circuit in the VCC3 wire, which supplies voltage to the sensor. If this wire has continuity issues or is damaged, the sensor will not receive the necessary voltage, leading to incorrect readings. Finally, poor connections or faults along the signal wire, known as THL1, may result in providing erroneous signals to the PCM, triggering the DTC in question. Systematic inspection of these components is necessary to identify the root cause effectively. The manifestation of DTC P0122 can lead to noticeable symptoms that impact vehicle operation. A common symptom is the illumination of the check engine light on the dashboard, signaling potential issues within the engine management system. In addition, drivers may experience poor acceleration performance, as the PCM may not receive accurate TP sensor data to optimize fuel delivery. Unstable engine idle is another possible symptom, where the engine may hesitate or fluctuate in RPMs due to incorrect throttle position readings. These symptoms can significantly affect drivability, making it crucial to address the underlying issues to prevent further complications. The first step in troubleshooting DTC P0122 requires you to turn the vehicle ignition to the on position without starting the engine. Once in this mode, the Honda Diagnostic System, or HDS, should be utilized to check the voltage output from the TP Sensor A. If the displayed voltage is less than 0.3 volts, it confirms the presence of the fault, allowing you to focus further diagnostics on the throttle body and associated circuits. This initial check provides a quick way to assess the condition of the TP sensor and guide subsequent testing and inspection procedures. Make sure that any fault codes present in the HDS are noted for further analysis. For the second troubleshooting step, disconnect the throttle body connector, which typically has a 6-pin configuration, to prepare for further inspection. With the connector unplugged, use a multimeter to measure the output voltage of the connector pins while in the ignition on mode. The expected output voltage is approximately 5.0 volts under normal conditions. If the voltage reading meets this expected range, It indicates that the throttle body may not be the root cause of the issue. Conversely, if the voltages deviate significantly from 5.0 volts, further investigation into the throttle body and potentially damaged wiring becomes necessary. This step helps isolate the problem for effective rectification. Next in the troubleshooting sequence is inspecting the VCC3 circuit for open wires. This step involves disconnecting both the throttle body connector and the PCM connector because you want to ensure a proper inspection without interference. With the ignition turned off, measure the resistance across the VCC3 wire. A reading of less than 1 ohm indicates a healthy wire connection, while higher values suggest a possible open circuit or problem within the wiring infrastructure. Identifying any discontinuities in the power supply to the TP sensor is critical, as it can directly impact its performance and cause the DTC to appear. This test narrows down the potential issues to the wiring and circuit integrity. The fourth troubleshooting step focuses on the THL1 signal wire, which carries the sensor output back to the PCM. Following the previous disconnection of both the throttle body and PCM connectors, ensure that the THL1 signal wire is inspected for shorts to ground. This step involves using a multimeter to measure the resistance from the signal wire to the vehicle chassis. It is crucial that the resistance exceeds 1 megaohm to confirm that there are no shorts. A reading lower than this indicates that the wire may be damaged or compromised, causing the DTC to register due to inaccurate signals being sent to the PCM. This step reinforces the importance of integrity in both the signal path and its connections. The final troubleshooting step involves inspecting the powertrain control module, PCM, which is responsible for processing signals from various sensors, including the TP sensor. If all previous inspection steps have indicated normal operations, it leads to the likelihood that the PCM may be at fault. This involves checking for any diagnostic trouble codes other than P0122, assessing its power supply and ground connections, and validating its functionality. Since the PCM is an electronic unit, it can develop faults over time, adversely affecting its ability to communicate properly with the throttle position sensor. If diagnostics confirm that the PCM is indeed faulty, it will require replacement to resolve the issue effectively. Upon completing repairs identified through the troubleshooting process, it is imperative to conduct a final verification step. Start by utilizing the Honda diagnostic system to clear the DTCs from the PCM, which resets the system's memory. Subsequently, perform a test drive under various driving conditions to evaluate the vehicle's responsiveness and engine performance. During this test, pay attention for any symptoms indicating a repeat of the trouble code, such as poor acceleration or the check engine light reappearing. If no reoccurring issues arise, it confirms that the repairs were successful. Documenting the outcome ensures a record of the repair process and mitigates future occurrences of the same error. Engaging in preventive maintenance can significantly reduce the likelihood of future occurrences of DTC P0122 and improve the longevity of vehicle components. Regularly schedule cleaning of the throttle body to prevent carbon buildup, which can interfere with the TP sensor's readings. Additionally, routinely inspect the wiring connections around the throttle body and PCM for signs of wear, corrosion, or damage, as these could lead to circuit failures. It is also advisable to monitor voltage supply visually when servicing related components to ensure that all electrical connections remain secure. By adopting these preventive measures, potential issues can be caught early, promoting overall vehicle reliability and performance. In summary, DTC P0122 indicates that there are issues with the throttle position sensor A causing low voltage conditions. Systematic troubleshooting, following the defined steps, allows for effective identification of the problem, whether it's with the sensor, wiring, or PCM. Each step plays a crucial role in narrowing down possible failures and facilitating accurate repairs. Regular preventive maintenance is equally important to ensure the longevity of the throttle body and sensor circuitry. Awareness and proactive engagement with these aspects will enhance vehicle reliability, ensuring that performance remains optimal over time. Please like and subscribe to the channel. See you next time.